lecture, I would like to explain about features of 8086 microprocessor. In features of 8086 microprocessor, the first one is it is a 16-bit microprocessor. Before the 8086 microprocessor, we have 8085 microprocessor. 8085 microprocessor is a 8-bit microprocessor. So in 8085 microprocessor, we have some drawbacks. So in third generation, the 8086 microprocessor was designed, and it is a 16-bit microprocessor. And second one is 8086 is a third generation microprocessor, and it is designed by using HMOS technology. Here we have generations of microprocessor, and the first one is the first generation microprocessor is 4-bit microprocessor, and the examples of 4-bit microprocessor is 4004, and this is the example of 4-bit microprocessor. And second generation microprocessor is 8085 microprocessor, and the third generation microprocessor is 8086 microprocessor, and it is designed by using HMOS technology. Here, by using HMOS technology, they designed 8086 microprocessor. And the third one is it is a 40-pin dual in-line package. And 8086 microprocessor contains 40 pins, and it is in a dual in-line package. Dual in-line package is nothing but this IC contains pins in both sides. Both sides of the IC it contains pins. One side 20 and another side 20, both 40 pin IC. It is a 8 pin 40 pin dual in line package IC. And fourth one is it contains 20 address lines and 16 data lines. Here 8086 microprocessor consists of 20 address lines and 16 data lines. Here address lines in 8085 microprocessor, it contains 16 address lines and 8 data lines. 8085. Here in 8086 it contains 20 address lines and 16 data lines. Here one point we kept in our mind is that it is a very important point. We have to remind that here data lines is depends upon the bit capacity of microprocessor. Here in 8086 microprocessor, it is a 16-bit microprocessor. So it is a 16-bit microprocessor, so that's why it has 16 data lines. In 8085 microprocessor, it is a 8-bit microprocessor, so in 8085 it contains 8 data lines. This is the one important point. Data lines is equal to the bit capacity of microprocessor. It is a 16-bit microprocessor, so that way it has 16 data lines. And another one is the memory capacity of 8086 microprocessor is 1 MB, and in the 8085 micro memory capacity is 64 KB only. In this 8086 microprocessor, it contains 1 MB memory capacity, that is 2 power 20 equal to 1 MB. In 8085 microprocessor, 2 power 16 equal to 64 KB. Here memory capacity depends upon the address lines. Again, this is also one important point. Here the memory capacity depends upon the address lines. In 8085 microprocessor, it contains 16 address lines, so 2 power 16 equal to 64 KB. In 8086 microprocessor, it contains 20 address lines, so 2 power 20 equal to 1 MB. And another one is it has 16-bit ALU. ALU is nothing but a arithmetic and logic unit. Here arithmetic and logic unit is used to perform arithmetic and logical operations. Here arithmetic operations is like addition, subtraction, multiplication, division, modulus. And logical operations are nothing but and, or, not, NAND, NOR, XOR and XNOR. This for arithmetic and logical operations ALU is used. Here another important point is here ALU is also depends upon the how many bits ALU is also depends upon the bit capacity of microprocessor. Here the bit capacity of 8086 microprocessor is 16 bit, so it consists of 16 bit ALU. It is also one important point. Here we have to remind that the bit capacity of the microprocessor and the data lines and the ALU is depends upon the bit capacity of microprocessor. In 8085 microprocessor, it is a 8-bit microprocessor, so that contains 8-bit ALU. This contains 16-bit ALU. And clock frequency of 8086 microprocessor is 5 MHz. Here clock frequency, we have to use clock frequency. In clock frequency of 8086 microprocessor is nearly 5 MHz. And 8086 has high interrupt handling capability. And 8086 has so many interrupts, so it has high interrupt handling capability, and it consists of 14 16-bit registers. 8086 contains 14 16-bit registers. Here in 8086 microprocessor, it contains general purpose registers, special purpose registers, and index registers, flags. Here AX, BX, CX, DX are nothing but those four are general purpose registers, and CS, DS, SS, ES, these are all the special purpose registers. And here SP is nothing but a stack pointer, base pointer, IP is nothing but instruction pointer, DI and SI are index registers. Here DI is nothing but a destination index and SI is nothing but a source index register. And flags. Flags are used to indicate the output of the output indication of the after performing arithmetic and logical operations. Suppose when we perform addition of two bits or bytes, then we get carry in the output. To indicate carry, then carry flag indicates the carry if the carry is generated, and if we get negative in the output of the after performing addition of two operands, then the sign flag is indicated by 1. In this way it shows the output of the after performing addition and logical operations. And segmentation is possible in 8086 microprocessor. In 8086 microprocessor, segmentation is possible, but in 8085 microprocessor, segmentation is not possible, and it has most powerful instruction set compared to 8085 microprocessor. 8086 microprocessor contains most powerful instruction set. And another one is it has 6-byte long queue. Here by using 6-byte long queue in 8086 microprocessor, we have to increase the speed of microprocessor, which follows pipelining. Pipelining is nothing but with pipelining means if one instruction is suppose in t1 time, if the first instruction is executing, here we have to for execution of any instruction, we have to two steps: fetch and execute. If in t1 time the first instruction is executed, then after that in the same t1 time the next instruction will be fetched. So this is called as pipelining concept, and it performs FIFO. Here FIFO is nothing but a first in first out operation. This 6-byte long queue performs first in first out operation. And another one is 8086 operated in two modes. Here 8086 microprocessor is operated in two modes. First one is maximum mode and second one is minimum mode. Here we have to remind that it operates in two modes, and maximum mode and minimum mode. And it requires plus 5 volts DC supply. Every circuit requires supply to operate. So in this 8086 microprocessor requires plus 5 volts DC power supply. and it consists of 9 flags. 8086 consists of 9 flags. We already discussed about what is flag. So among those 6 are conditional flags and 3 are control flags. And it consists of 16-bit stack pointer. He already learned in 14 16-bit register. It consists of 16-bit stack pointer. And these are the some of the features of 8086 microprocessor. Thank you. If you like this video, you can subscribe my channel, and in another lecture, next lecture, I would like to explain about 8086 pin diagram and description. Thank you.